Number 4 from section 1.8. Let's take a look at the instructions. Find all x in R4 that are mapped into the 0 vector by the transformation x into AX for the given matrix A. Okay, so we want essentially AX to be 0 because let's think of this as the 0 vector. Just imagine that it's bold-faced. Okay, so notice that I really just have to set up the augmented matrix, the following augmented matrix. I really just have to add a column of zeros. All right, because this is the augmented matrix for this system. So let's try to put this thing in at least echelon form, if not reduced echelon form. So I'm going to take the first row, multiply it by -2, add it to the third row. -2 times -5 is 10, minus 8 is 2. -22 plus 14 is -8. And then 6 minus 2 is 4. That'll stay as 0. Okay. So we actually have to solve this system. It's not enough to just decide if there's a non-trivial solution. So let's move on to the second column. And I'll multiply the second row by -2 and add it to the third row. -2 times that is +8. If I add to that, I get a 0. Notice I get another 0 there. So I get a whole row of zeros. Now let's get rid of the -5. So I'll multiply the second row by 5 and add it to the first row. 5 times this is -20, plus 11 is -9. 5 times that is 10, minus 3 is 7. That'll be a 0. Okay, so that looks like it's in reduced echelon form. And it looks like we probably have multiple solutions for this thing. Okay, so let's try to decide which variables are basic and which variables are free. It looks to me like the basic variables are x1 and x2, because those are the two pivot columns, the first and the second. And we have two free variables in this case. So the free variables are x3 and x4. So let's try to express the solution set, just like we did in previous sections. So I'm going to go ahead and write the first equation. It's x1 minus 9x3 plus 7x4 equals 0. So let's solve for x1. Okay. And then we'll go ahead and write down the second equation from the matrix, which is x2 minus 4x3 plus 2x4 equals 0. Solve for x2. Okay, and just keep in mind that x3 and x4 are free. Okay. So how should we write the solution set? And it looks like the computer wants us to enter it a certain way. It looks like they want us to enter it in parametric form. Just remember that any solution of this system is going to be a 4x1 vector that looks like x1, x2, x3, x4. So what you usually do if you try to express this in parametric form is just leave the free variables where they are, x3 and x4, but replace x1 with this, 9x3 minus 7x4, and we'll replace x2 with this, 4x3 minus 2x4, and we'll just leave the last two alone. Not quite done yet, because I'm going to break this up into a sum. Okay, So the first thing you want to do is factor out all the coefficients of x3 and then write down the 4 by 1 vector corresponding to x3. So notice that all the coefficients of x3 are 9, 4, 1, and 0. All right. And now factor out the x4 and write down all the coefficients of x4. It looks like -7, -2. And that's a 0 for x4, 0, 1. So that is the general solution of the system. And just keep in mind that x3 and x4 are arbitrary.